Our next lesson in graphing linear relations is to work with equations in different forms and be able to convert them into y equals mx plus b form. So there are three equations here, and the question is, what do these equations have in common? So here, both of these two have a 2x and they both have a 3y. The only difference is in the first one, 24 is on the right-hand side. But if you transpose that 24 and bring it to the other side of the equation, it becomes a negative 24. So in fact, these two equations are the same. They're just different variations of each other. And this one is also a variation of the first one. What happens is, if you start with 2x plus 3y equals 24, and you work towards isolating y, and we are going to transpose the positive 2 to the opposite side and make it negative. Now we are going to divide both sides of the equation by 3 and continue to simplify where possible. Negative 2/3 does not divide, so we leave it as a fraction, and 24 divided by 3 is positive 8. So this here is also the same equation. They have just been rearranged into a different format. And that's what we have to work on today, is taking our equations from one format and converting them to the other. The preference is always to work in y equals mx plus b form, because this makes it so much easier to do our graphing. We plot the y-intercept at positive 8, and from there we go down 2 because we have a negative rise, and forward 3, plot a point and continue, and we can then figure out our graph. And we've got the two key pieces of information that we like to have, the slope and the y-intercept. Now, even if your equation is not in this format, it is noted in the homework booklet that if you have an equation in this format, meaning the x and y terms are on the left-hand side and there is a constant term on the right, in this particular case, the slope, oops, there's a mistake here, that should be the letter little m, is equal to negative a over b, and the y-intercept is c over b. So going back to 2x plus 3y equals 24, you can actually see that the a value is 2 and the b value is 3 and c is 24. So based on this, the slope is the negative of a over b, which is now negative 2/3, which matches what we have up above. And the y-intercept is c, 24, over b, which is 3, which simplifies to give us 8. Okay. But we don't necessarily want to do these calculations. It's a matter of preference. In fact, I personally prefer to take my equation and rearrange it into y equals mx plus b, which we just did over here. Okay. So this all comes back together to the idea of graphing. So if I have an equation such as this, there are three different ways that we can now graph this. So one method is to use a table of values. And again, you choose the values for x and you find its partner y. So I'm going to choose x is, let's pick negative 1, maybe 0, and maybe positive 3. I'm just randomly picking 3 values for x. And then I have to find the partner y by replacing x in the equation with negative 1. So it's 2 bracket negative 1 plus 3y equals negative 6. So that'll be negative 2 plus 3y equals negative 6. bring over the -2 to the opposite side to get +2. So 3y equals -4. So it's -4/3. Now, you can see it gets tricky here because we are going to end up with some decimal values here, which is going to make the graphing a little bit tricky. So this is why I would say at this point, this is not our best option. So if x is equal to 0, we have 2 brackets 0 plus 3y equals -6. 3y equals -6, so y equals -2. And if we pick x is 3, I'm just trying to show my work down here. 2 bracket 3 plus 3y equals -6. 6 plus 3y equals -6. This is going to get transposed to the other side and become negative. So that's going to give us -12. So it's going to be -4. So I have 3 points that I can plot on my graph. 0 and -2, 3 and 1, 2, 3, 4. And the -1 and -4/3 is right about here. Okay. So this point here is a little bit questionable. But what we can do is we can go back and we can think about other ways to graph. So another way is to take our equation as it is and rearrange to get it into y equals mx plus b form. So we start by transposing the +2 to the opposite side and it becomes -2x. The -6 stays on the right, so it does not change. Then we divide both sides by 3. So y will equal -2/3 x, and -6 divided by 3 is -2. So we have our y-intercept at -2. Our y-intercept is -2. There it is. And to find a second point, you would go down 2 and over 3, and then bingo, we're right where we had already plotted a point. But I can continue this trend to go down 2 and over 3. 1, 2, 3. And from the y-intercept, I can do the opposite. I can go up 2 and over 3. Yeah, the opposite would be up 2 and 3 to the left. 1, 2, 3. And so following that, I now have a lot more points that I'm going to connect. So that's another way of doing the graph. The third way is to find the intercepts. So the x-intercept, okay? The x-intercept is where your graph crosses the y-axis, and when you cross the y-axis, the y value is equal to 0. Sorry, when you cross the x-axis, the y value is equal to 0. So we're going to let y equal 0. So we'll have 2x plus 3 bracket 0 equals -6. So 2x equals -6, x equals -3. So that corresponds to the point -3, 0. And if we go back, in fact, we can see that based on our previous method number 2. And for the y-intercept, we're going to let x equal 0 and solve for y. So 2 bracket 0 plus 3y equals -6. 3y equals -6, so y equals -2. So that corresponds to the point 0 and -2. And there we have both of those points. There's our x-intercept, and there is our y-intercept. And so everything is matching up from the different formats. Everything is working out just right. So we are confident that we have the right answer. I just need to find my ruler, and then we can connect these 2 points. Oh, there's more than 2 points. We connect all these points, and we use a ruler. That's important. Use a ruler, add some arrows to show that this relation continues in both directions. Okay, so we've got some additional examples on the opposite side. So this time we're going to really focus on graphing using y equals mx plus b. So we have 3x minus 6y equals 18. So we're going to start by transposing the 3x to the opposite side, and it becomes negative. Now this time the numeric coefficient in front of the y is negative, so y is being multiplied by negative 6. So the opposite would be to divide by negative 6 to get a positive 1y. Since we divide the left side by negative 6, we do the same thing on the right hand side. Both terms on the left hand side need to get divided by negative 6. Negative 3 divided by negative 6 simplifies to give us 1/2 x. 18 divided by 6 reduces to negative 3. So now we have a slope of 1/2, and we have a b value of negative 3, which is our y-intercept. So to quickly graph this, we go to the y-axis and we go to negative 3. This is a point on our graph. We find additional points using the slope. The slope is positive. That means both the rise and the run are positive. We are going to rise up 1, and the run is 2. So up 1, forward 2, up 1, forward 2, up 1, forward 2. We can actually see that we have an x-intercept at 6. So we were able to identify the x and y intercepts from our graph. So I'm going to connect my points, draw my arrows, and we have answered the question. Okay. Example number 3. Again, we have an equation that is not in y equals mx plus b form. To graph this, we are going to rearrange it into y equals mx plus b. So the positive 7x transposes to the opposite side, and it becomes negative. I like to put it in front of the negative 21, which was already on the right-hand side, because now it's in that proper format. We divide both sides by 3. We have a negative over a positive, and 7 does not divide evenly, so we're going to leave that as a fraction. And negative 21 divided by 3 is negative 7. So we have a negative slope, and we have a negative y-intercept. So to graph, we're going to go to our y-intercept at negative 7. And now I need to graph this. Now I've got a problem, because according to this, I'm going to go down 7 and forward 3. But that's going to take me right off my grid. So what you can do is you can do the complete opposite. So instead of going down 7, I'm actually going to go up 7. So there 1, 2, 3, 4, 5, 6, 7. And I'm going to go backwards 3. And there we go. And now we can continue that pattern, and we have points that we can graph. And we can actually see x-intercept and y-intercept on this particular graph. Now, what happens if I give you some information? I want you to come up with the equation for the line that has intercepts at 0, 5, 0 and 5, and 7 and 0. How are we going to figure out the equation of this line? So I'm going to guide you through the process. And what we do is we plot the 2 points. We can see that the y-intercept is at positive 5. So this is our y-intercept. This is our x-intercept. And what we want to do is we want to calculate the slope. So from our graph, I had to go down and I had to go forward. So you went down 5 and forward 7. So that means our slope is down 5 I went down 5, so I have a negative rise, and I went forward 7. So my slope is negative 5 over 7. And I got that right from my graph. The y-intercept is at positive 5. So now to come up with the equation in y equals mx plus b form, when you look at it, there are 4 different variables. We need to actually come up with the specific values for m and b, which we just did. So we know that the slope for our particular line is negative 5 over 7, and we multiply that by x, and our b value, or our y-intercept, is positive 5. And now we have created the equation of our line in y equals mx plus b form.